Welcome to today's Explainer. We are cracking open a biological mystery so absolutely massive, it honestly sounds like CGI from a monster movie. We're going to travel back in time to a world that was just recovering from the extinction of the dinosaurs. A world ruled by a creature so enormous it literally defies belief. But you know what the most incredible part is? The secret to this giant's very existence holds a mirror right up to the Earth's ancient climate, and, well, maybe even our own future. Let's dive in.
So, our story actually starts in modern-day Colombia, specifically at Cerrejón. Now, this is one of the world's largest open-pit coal mines. Just picture it, amidst all these massive, rumbling machines digging up hundreds of tons of coal to power our modern world, a geologist student on a field trip happens to notice perfect fossils etched right into the mine's walls. We're talking leaves, plants, seeds, all belonging to a lush jungle that existed around 60 million years ago, right after the dinosaurs vanished. Obviously, scientists quickly realized they needed to dig a whole lot deeper.
And man, when they dug deeper, what they found was just astonishing. They pulled out these massive bones. Naturally, at first glance, everyone assumed they had found the remains of an ancient giant crocodile, right? I mean, that's a pretty logical guess for the ancient swamps of South America. So they shipped these fossils off to the Florida Museum of Natural History. But when a snake expert there began unwrapping these bones, he literally froze. Looking closely at the shape and the curve of the skeletons, he realized everyone was completely wrong. These definitely weren't crocodile remains. They were the vertebrae of a monster-sized snake. The scientific community had just stumbled upon a creature whose size was entirely unrecorded in history. They named it Titanoboa. All right, bringing us to Section 1, unveiling the Titanoboa, the largest snake in Earth's history.
To really wrap our heads around the sheer scale of this creature, we've got to look at the volume of data published by Jason Head's team in the journal Nature back in 2009. They didn't just find, one random bone. They examined 186 fossil specimens from roughly 30 different snakes unearthed right there at Cerrejón. It's this absolute mountain of data that gives scientists so much confidence in their math. By comparing these ancient bones to modern snake vertebrae, they initially estimated a length of 12.8 meters. But wait, later skull discoveries actually pushed that number even further, revealing this giant could reach an astonishing maximum length of 14.3 meters. That is almost 47 feet long.
And the sheer mass is just as staggering. We're talking 1,135 kilograms. That's over 2,500 pounds. Think about this. If Titanoboa somehow reared up in front of you right now, the diameter of its body at its thickest point would reach all the way up to a standing human's waist.
To truly put this into perspective, let's contrast it with our modern heavyweight champion, the green anaconda. As you can see, Titanoboa was almost double the length and roughly 5 times the weight. If you saw this ancient snake stretched out on a road today, its body would be the exact length of a full-size school bus. And remember, these aren't just wild sci-fi guesses. These are published, peer-reviewed scientific facts derived directly from those Cerrejón fossils.
Which leads us to Section 2, Climate, Metabolism, and Size, the core scientific mystery.
So, Titanoboa's story isn't just some cool monster tale. It actually presents a genuinely profound biological puzzle. How on earth did a snake physically grow to such extreme proportions? You could search the Amazon, the Congo, or Southeast Asia today, and you won't find anything even remotely close. To solve this, we really need to understand the fundamental link between ancient climate change and snake growth rates. It all comes down to a really simple rule of biology. Snakes are cold-blooded, or poikilothermic. That means they cannot internally regulate their own body temperature. Instead, they rely entirely on the heat of their external environment to drive their metabolism. The equation is simple, but incredibly powerful. A warmer outside environment equals a faster metabolism. And a faster metabolism means the animal's body can grow at a massive, accelerated rate. Now, if Titanoboa needed extreme heat to reach the size of a school bus, scientists realized they could actually use the snake itself as a tool. They coined the term paleothermometer. It is absolutely brilliant, honestly. By looking at the massive size of the fossilized snake, researchers can essentially work backwards to calculate the exact temperature of the ancient Earth. Using this paleothermometer concept on the massive volume of Cerrejón fossils, Jason Head's team made a really bold claim in 2009. The math revealed something staggering. While today's absolute warmest tropical forests average around 26 to 27 degrees Celsius, the calculations showed that for a snake the size of Titanoboa to just survive, let alone thrive, the ancient environment had to average between 30 and 34 degrees Celsius. That means the world Titanoboa lived in was a staggering 4 to 8 degrees hotter than our hottest jungles today.
However, as you know, science is all about healthy debate. Another perspective emerged, arguing that this direct climate-to-size link might be just a bit too simplistic. Some experts point out that snakes aren't just passive thermometers. They actually use behavioral regulation, meaning they cool themselves down by retreating into water or hiding out in the shade. Because they can manipulate their immediate body temperature this way, using their absolute fossilized size to estimate the global climate might be slightly misleading. So this scientific argument is actually still wide open today.
All right, moving to section 3, inside the ancient rainforest, a high-temperature world.
Regardless of the exact degree, we know for a fact this was a hyper-warm world. So let's step inside it for a second. Imagine traveling back 60 to 58 million years ago. The Sarajon mine acts as a perfect time capsule for this ancient neotropical ecosystem. This was a world with 0 icebergs, 0 ice caps, and absolutely 0 winters. The heat was consistent year-round, and the moisture in the air would have been suffocating. And Titanoboa wasn't the only giant hanging around. Fossils show this suffocatingly hot environment birthed giant turtles the size of pool tables, literally big enough for you to lay out on, living alongside early, heavy-jawed crocodiles with blunt-crushing teeth.
So, how did our giants survive in this swamp? Well, initially people thought it hunted on land, but a 2011 expedition uncovered 3 Titanoboa skulls, which is a massive rarity. The anatomy of the jaws and teeth proved this wasn't a land-chasing monster at all. It was actually a semi-aquatic ambush predator. Picture a murky, dark river stained almost black by tannins. Titanoboa would submerge itself, leaving only its eyes and nostrils above the surface, and it would wait completely motionless for days. When a giant fish or one of those heavy-jawed crocodiles swam by, it would strike in an absolute flash, constricting its prey and consuming it whole.
Which brings us to our final chapter, section 4, the extinction enigma. How did the invincible fall?
So, we have an apex predator, perfectly adapted to its high-heat environment and completely unrivaled. Honestly, nothing could touch it. But around 58 million years ago, Titanoboa just suddenly vanishes from the fossil record. Think about this. 65 million years ago, an asteroid wiped out the dinosaurs, but Titanoboa survived that aftermath, reigning supreme in that high-heat climate. Yet later, with no cataclysmic explosive mass extinction event, it disappears entirely. Why? Well, the answer lies in a dramatic shift in the Earth's climate.
There are 2 heavily debated theories here. The first is global cooling. Simply put, the Earth's average temperature began to drop. Remember our biology rule from earlier? A cold-blooded giant needs massive, massive heat. Without it, Titanoboa's huge body simply couldn't sustain its metabolism. The second theory points to the exact opposite, the Paleocene-Eocene thermal maximum. This was a massive and rapid global warming event. This extreme shift could have drastically altered the landscape, the water systems, and the food chain, essentially wiping out the giant prey that Titanoboa relied on.
Now, the exact definitive reason for its extinction remains an unanswered question, but the lesson it leaves behind is undeniable. To quote the researchers, like a giant snake that seemed invincible, whole species can vanish in the blink of an eye due to slight environmental changes. Nature provided the absolute perfect situation for this creature to become the largest snake in history. At the very moment the weather, the prey, and the climate shifted, it was erased from history as if it never even existed.
Which leaves us with a stark reality to consider. Humans grew and thrived in a perfectly balanced global environment. Yet today, through pollution, melting glaciers, and reckless environmental practices, we are rapidly shifting that very climate. Titanoboa teaches us that size, dominance, and a seemingly invincible position in the food chain offers 0 protection against a changing Earth. If an apex predator the size of a school bus can vanish in an evolutionary blink of an eye due to shifting temperatures, what does that mean for us? I'll leave you to think about that. Thanks for joining me on today's Explainer, and keep questioning the world around you.